Welcome. We have here a case of lawn bowling in which we have a 3 kilogram pilot ball hits a target 5 kilogram ball. But in this case, both of them are moving in the same direction. And we're going to say they have an elastic collision. And we want to find the final velocities of these two. So we have a problem because our elastic collisions when v2i equals 0, we can use these equations. But we can see pretty clearly in our knowns and unknowns that v2i is not 0. So what we're going to have to do is we're going to have to use another way of thinking about this. What we can say is that we can say velocity of 2i relative to the ground is 2 meters per second. And then we know that the velocity of 2i relative to itself should be 0. So now we can go into this and say, well, we know that velocity of 2i relative to 2i has to be equal to, right, velocity of 2i times something, or velocity of 2i relative to something, plus the velocity of something relative to 2i. Well, we know this is 0, and we know 2i relative to g. If we put g here, then we get this is plus 2 meters per second. And we have to have whatever these two are be the same, so then this also has to be g. In order to 0 equaling 2 meters per second plus something else, this would then have to be negative 2 meters per second. So we can have here in our knowns then that the velocity of g relative to 2i, this is the velocity of the ground relative to ball 2i, is equal to negative 2 meters per second. So if we can do this, we can transform to the 2i frame where then the velocity of 2i relative to 2i is equal to 0. So now I need to find the velocity of 1 initially relative to 2i. If I'm doing this, as I had with my relativity, I have to have the velocity of 1i relative to something plus the velocity of the same thing relative to 2i. And these have to match. Well, what do I know? I know that my velocity of 1i relative to the ground is 7 meters per second. So if I have this be g here, then this also has to be g. I know v1ig is 7 meters per second, and I know that vg2i is negative 2 meters per second. And so then my v1i of 2i is then 7 minus 2, or 5 meters per second, which is my v1i in the frame of 2i. So in my unknowns, now I can solve for the velocity of 1f in the frame of 2i. I can solve for the velocity of 2f in the frame of 2i. But what I'm really trying to find is the velocity of 1f relative to the ground and the velocity of 2f relative to the ground. So my first step is I can use these elastic equations in the 2i frame. So the velocity of 1f in the 2i frame is mass 1 minus mass 2. mass 1 is 3 kilograms, mass 2 is 5 kilograms, over mass 1 plus mass 2, 3 plus 5, times the velocity of 1, I, in the 2I frame, because everything is in the 2I frame. So this is 2 divided by 8 times my 5 meters per second. And so I get negative 2, negative 1.25 meters per second. And I can use this similar equation for V2F in the 2I frame is 2 times m1, so that's 6, over m1 plus m2, which is 8, times v1I in the 2I frame, which is 5 meters per second. And so I get for this 3.75 meters per second. So I've just found V2F in the 2I frame is 3.75 meters per second. How do I find 1F in the ground frame? So this is my last step, is to transform back. So I have V1F in the ground frame. This is going to be V1F times some shared measurement plus V of some times shared measurement ending with G. So what do I know? I know V1F 2I and I know VG 2I or 2IG. So I can have these two be 2I and 2I, right? They again have to match. And so I can read off what I've already written. So V1F in the 2I is negative 1.25. Meters per second. V2 I in G is 2 meters per second. So V1F is 0.75 meters per second in the original frame. Excellent. So I've got half of it. And now see if you can figure out, right, which two things to add for V2F in the ground frame. So pause and see if you can solve. So we need V2F some shared measurement plus V of some shared measurement relative to ground. And again, these have to match. Well, I know 2F and 2I, and I know 2I and G. So I can put 2I and 2I here. V2F 2I is 3.75 meters per second, and V2I and G is 2 meters per second. So V2F is 5.75 meters per second in the original frame. So, was this math very hard? We are just adding and subtracting 2 meters per second a whole bunch. We are using this equation, which isn't too scary. What's crazy is, right, the subscripts will get us forgetting or panicking how to match these things. So just writing these out, writing again out our knowns and unknowns so you can keep track of everything, keep track of the subscripts is absolutely key for relativity. But once we get that, then the math turns out to be as easy as we can do in this class.